Okay, there is a last question here. Again, this was taken from the Electrical Installation Maintenance Group here in our country, in the Philippines. No? Okay. From Ash here M. Vladimir. Okay, from Ash here. No? Hirap ng mga pangalan nila. Okay? So, hirap din kasi. So, pwede po ba magtanong? Nagtanong ka na no? Huwag mo na itanong kung pwede. Oh. So, mga master, okay, ano po ba ang pagkakaiba ng demand factor sa power factor? Okay? Sabi ni Asher. In English, may I ask, masters, what is the difference between demand factor and power factor? That is totally a different thing. Okay, I will shortcut this with you. I will discuss first what is power factor. What is power factor? Let's go over here. What is power factor? Okay, from alternating current circuits, what is power factor? Power factor is equal to cosine theta. Power factor actually has so many, it has one definition, that is cosine theta. But the theta here has so many meaning, this theta. This theta is the theta in the three very important triangle in alternating current circuits. Okay, we have the impedance triangle. So this is our Z, resistance R, and reactance X. This is the theta. In power triangle, we have the apparent power, the real power. Okay, then we have the reactive power. Then we have another theta. And then there is another triangle in alternating current circuit. That is the admittance triangle. This is the admittance, which is the opposite of impedance. Okay, so this is the conductance and this is the susceptance. Remember, our Y here is 1 over Z. Our G here is 1 over R. Our beta here is 1 over X. There is a theta here, no? Here, this is the theta. That is all 90 degrees. Don't you know that all this theta has the same angle? They are not different. If this is 30 degrees, this should also be 30 and 30. Galit kaya ito, sir? Hindi naman. That is what you call emphasis. I have to emphasize these things with you guys. The impedance angle, the apparent power angle, and the admittance angle are all the same. Get the cosine, that's the power factor. That's the power factor. Then there is another consideration about the power factor. Let's go here. Let's say you have your voltage waveform. And you have your current waveform here. That's your current waveform. Considering the starting point of this waveform, the starting point for the current, this is the starting point for the voltage. You are to get their phase displacement. Let us get their phase displacement. Considering the distance between the two starting points. What is the starting point? It is the point wherein the next point is going to the positive direction. What do I mean? What do I mean? If you have your waveform like this, question, is this a starting point of this waveform? From left to right? No, this is not the starting point because the next point is already negative here. The starting point of this waveform is this point. Then the next point here will become positive. That is now the instantaneous value. That is the positive and the negative value. Now, looking at this is our theta. That is our theta, which is the difference. That is the phase displacement between the voltage and the current. Okay? That is the power factor. Take the cosine. Take the cosine of the phase displacement between, take a look here, the voltage and the current. They have the theta here. If this is 30 degrees, this is also 30 degrees, 30 degrees, and 30 degrees. All of them are 30 degrees. But it doesn't mean they have the same magnitude here. Doesn't mean like that. They have all the same angle only. Not necessarily the same magnitude here. But of course, there is a certain proportionality with the three. What do I mean? Mathematically, let's say if you have a large triangle here, okay. See, let's say you have this triangle. Let's say this is your impedance triangle, or this is your power triangle, this is your admittance triangle. See, they are all similar triangle, but they have the same angle, isn't it? They have the same angle. Just get the cosine theta. That is the power factor. That is my answer to the power factor. But sir, what do you mean by demand factor? That is totally a different thing. What is a demand factor? Okay. You can make use of this in the licensure examination. No? Pwede lumabas to sa board exam, ha, mga kawerpa. What is demand factor? I have a note here. You can screenshot this. No? What is demand factor? Demand factor, it is the ratio of the peak load to the connected load. Demand factor is the peak load. Peak load meaning that is the maximum load. Let's say you have a load graph, no? There is a time that it has a peak load, no? Mataas yung konsumo ng energy mo, kuryente mo. There is a peak load. Okay? Ratio of the peak load to the connected load. What is the connected load? What is connected load? Connected load, that is the sum of all loads. Okay? Installed or connected to the system. That is connected load. That is the ratio of the peak load to the connected load. Meaning that is the ratio of the maximum to the all the connected load. Let's say how many kilowatt all this load has. Let's say all this load has let's say it has 10,000 watts, all these loads, or 100,000 watts. Then there is a peak load that has 80,000 watts. So you divide. If that is expressed in energy, in kilowatt hour, it can be calculated. Anyway, the energy is just power times time. So you can have here the maximum kilowatt or kilowatt hour divided by the total connected kilowatt hour. Energy or power, you can make use of this formula. The demand factor is the ratio of the peak load to the connected load. It is being used in the power plant engineering and also being used in the electrical systems design, because they are assuming that you will not, in incising the wire and the circuit breaker, you will not all the loads here on a simultaneously. You will not operate all of them na sabay-sabay, no? You will not use it simultaneously. So maybe you can have a 0.6, 0.7, 0.8 multiplier. Well, the purpose is to reduce the size of wire. Mas mura kasi, mas maliit na wire. Thereby reducing also the size of the circuit breaker. There are designers doing that, introducing a demand factor That is in electrical design. And then also in the power plant engineering, of course, they are considering the load growth, no? The load graph, I mean, there is a load graph. Wherein you will see that this is at this time, let's say at 1 o'clock or at 3 o'clock, this factory uses that there is a peak load at 3 p.m., okay, divided by the total energy of these loads. That is demand factor. Diba? When we are sizing wires breaker, no, minsan may makikita kayo 0.85, 0.7. So ang katwiran kasi doon, no, the reason for introducing demand factor is you will not use all the load simultaneously. Even in our house, no, in our home, you can put a demand factor in doing the electrical design because there is an outlet, so too many outlets. You will not use all of them simultaneously. That's why you are introducing a demand factor. Okay? Para makatipid, no? For economic reason, that's one. Okay? But anyway, I saw a ratio here. Okay? Power factor can also be a ratio. Let me complete this. Let's go back for the power factor. Let's go back here. Nakita ko kasi may ratio yung demand factor. Pwede ka rin maglagay ng ratio dito. What is cosine theta? So, katoa, cosine is adjacent over hypotenuse. In the impedance triangle, it is R over C. In the power triangle, it is P over S. In the admittance triangle, it is G over Y. Okay? So, it is the ratio of the resistance to impedance, also equal to the ratio of the real power to the apparent power, also equal to the ratio of the conductance to the admittance. And that completes my answer. Thank you for this question. Okay.